Continuing with connective tissues, we are still on connective tissues proper, and I'm about to do the dense connective tissues. So we had a whiteboard that looked something like this last time, and we have already done all three of these loose connective tissues, which is a subcategory of connective tissue proper. Hopefully you remember what makes the tissues loose versus dense. Hopefully you remember that it's primarily how many fibers are packing the matrix. So now we're about to move to the dense connective tissues proper, and there are going to be three of those as well. Okay, so let's start looking at those. And first of all, let's see if we can identify why they are categorized as dense, first off. Okay, so these are sometimes called fibrous connective tissues. They tend to be less vascular than the loose connective tissues. They also tend to, because they're less vascular, have a little slower healing and regeneration than the loose connective tissues. There are tons and tons of fibers in the matrix, just packing the matrix. So let's look at a few of these. So this is the first one. This is called dense regular connective tissue. This is the same tissue. Hold on just a second, I'll show you a couple. This is dense regular as well. This one is still dense, but this one is dense irregular. Another slide of dense irregular, and still a third. And this one is elastic dense connective tissue. How did that get? There we are. Elastic dense connective tissue right here. So this is elastic dense connective tissue. So I want to look at, first off, hopefully you can understand why they're all categorized as dense connective tissues. These tissues aren't completely liquid and they're not completely solid. They're kind of squishy, but they've actually got a lot more fibers in them than the loose connective tissues proper. So they tend to be relatively strong comparatively speaking. So this one is called dense regular connective tissue. And the dense should be obvious because what you're actually seeing here is just between, here's a cell and here's a cell and here's a cell, and it's just packed with fibers in between those cells, just completely packed with them. So that makes it dense. And then what makes it regular? What makes it regular is that the fibers are running parallel to one another. Hopefully you can see what I mean by that. They're all running relatively parallel to one another. So dense and regular. This one is the same tissue. It's a little harder to tell on this one, but again, a whole bunch of parallel fibers. What kind of fibers are these? In dense regular connective tissue, you're looking at bundled collagen fibers running parallel to one another. That means that if you were looking at this tissue and you pulled on it from the ends, it would be super duper strong because of all of those bundled collagen fibers. Not so strong from this direction. So this tissue, you primarily find forming tendons, and a tendon is right here. A tendon is what the connective tissue that connects muscle to usually bone. And dense regular connective tissue also forms ligaments. The only difference really between a ligament and a tendon is that a ligament connects bone to bone, but it's the same tissue. And then the other thing that it forms is called an aponeurosis. And aponeurosis is, instead of a cable of tendon, it's like a sheet of tendon. So you've got a frontalis muscle, an occipitalis muscle, and then instead of a bunch of cables connecting them, you have a sheet of tendon. So you'll run into aponeuroses as well, and aponeurosis, plural is aponeuroses. Those are made of dense regular connective tissue as well. Okay, so strong in basically kind of unidirectional, not a bunch of directions. And then the next tissue, do it again. The next tissue is dense, still dense, but dense irregular connective tissue. So let's look at this one. You're going to find this one in what we call the reticular layer of the dermis down here. It's really strong, but it's strong in a bunch of different directions. So instead of bundled collagen fibers all running this direction, they're running in a bunch of different directions. So the metaphor is, instead of making one really strong rope, take the ropes and make a net out of it so that you can pull on it from a bunch of different directions. You can see it even better in, this is my favorite slide of dense irregular connective tissue, because you can see that some of the bundles of collagen fibers are running this direction, but then some of them you can see you got in cross section and they're running that direction. So this is really strong in a bunch of different directions. So this forms portions of the dermis of the skin. It also forms a fibrous capsule around some organs, and it forms the covering around your bone that you're going to attach ligaments and tendons to, called the periosteum. And it also forms the covering around cartilage that is called perichondrium, periosteum and perichondrium. Okay, so this is dense irregular connective tissue. We run into it quite a few times this semester. And then this is dense irregular as well, but that's kind of a hard slide. I probably wouldn't ask you on that one. And then this is elastic dense connective tissue. What you have with this one, first of all, it looks like kind of a mess. It's hard to tell what you're looking at, but if you have a whole bunch of dark bundles of fibers running parallel to one another, or relatively parallel to one another, it is elastic. These are elastic fibers, but they're bundled and parallel. So if you have enough elastics, you can get strength and elasticity. So this is elastic dense connective tissue. This is it as well. This one's a little further away, and this is it as well. Please note that what you see is parallel fibers, kind of wiggly, and some cells within this. This is elastic dense. This tissue, not as common as the other two. It's very strong because of the number of elastic fibers that you have, but it's also elastic because they're made of elastic. This is what makes up your true vocal cords, and also your intervertebral ligaments between your vertebra. Most ligaments are made of dense irregular, which is just collagen fibers. Those between your vertebrae need to be a little bit more stretchy. Also, you can remember that the elastic ligaments that hold up the penis do need to be kind of stretchy. So those are made of elastic, dense connective tissue. Now, in all three of these tissues, the primary cell that you're going to run into, now here it would be really hard to label a cell. They can say that's a fibroblast if they want to, but it just looks like another blob to me. It's not as hard to label them here. For instance, that's a fibroblast. Or here. In all of these three tissues, all of these dense tissues, the cell that you're going to run into most often, and which you should label, is called a fibroblast. Because remember, the term fibroblast means a fiber precursor or something that makes fibers. And of course, these are packed with fibers, so don't be surprised that there are lots of fibroblasts in there. Okay, now let's add those to our diagram that we were working on. So the three dense tissues, or three dense connective tissues proper, are dense regular, dense irregular, and elastic dense. Okay, so we got those. All right, so we'll stop there and I'll do the supporting connective tissues in the next little video.